Well, I'm ready whenever, Pablo. Just let me know.
Sure. Yeah, let's go ahead and start. It's almost 5 after.
All right. Well, welcome everybody to the Semgrep Summer Meetup for 2021. It's been a little while since we've done one of these, even longer since we've done one of them in person, but it's nice to see so many familiar faces in the crowd. I'm going to start off and give the most brief overview of Semgrep, what it is, but this is really more of a presentation for people who have been using Semgrep for a while or sort of familiar with the basic idea and are interested in a lot of the really interesting enhancements that the team has added and where the tooling is headed. So without further ado, real quick, Semgrep is a free and open source static analysis tool that supports many languages. The primary use case is security scanning, writing secure guardrails to educate developers, as well as your kind of general purpose bug finding and linting. And the general reasons why people would use it is because it's pretty fast, it's multilingual, and most importantly, it is very easy to write a new rule extremely quickly. So we've been really excited to see a lot of kind of top tier security teams and consultancies have adopted Semgrep since the last meetup, which has been awesome. And if you're looking for, like all the details, of course, semgrep.dev has that. Even more concretely, I think one interesting question is how is Semgrep different from other scanners that are out there? So this is a not an exhaustive or complete list, but the first thing is this is an open source tool, which definitely a lot of linters that's true for, but for a lot of kind of traditional static analysis commercial tools, that has definitely not been the case. And then all the other features here that you see listed, we're actually going to have updates on during the talk. So I will not keep you in suspense, and I'll give you the quick agenda for what we're going to be, how we're going to be breaking it down specifically. So you've got a kind of interesting cross-section of the R2C team here today. Emma is going to present on Semgrep enhancements. She's from the program analysis team. Colleen is going to talk about basically new improvements to the rule writing YAML syntax. She's from the security team, along with Vasily, who will be talking about our promotion of the Taint tracking engine to general availability. And then Drew, who's on the engineering side and is the CTO at R2C, will talk us through the upcoming Semgrep roadmap. And then when we come back at the end, I'll lead us in a kind of Q&A and discussion. So Emma, over to you.
All right, this is going to be hard because we've done a lot of stuff since launch, but I'll try to give you some highlights. So first of all, if you haven't been paying close attention, here's kind of where we're at. So we've gone from 800 to 1,400 public rules, a lot of them written by people in this call. We've also gone from, I think, 11 to 19 languages. I can't quite keep track because there are always so many being worked on, being added by other people, being added by us. So I might be off by one or two. We've also had a really big push to measure and improve our performance. So we can say that for about 95% of projects that have metrics enabled, Semgrep can scan their project in less than 5 minutes. Also, we've partnered with GitLab to start using Semgrep for their SAST. GitLab is actually, I see someone from GitLab here. So they've ported tools for a handful of languages like Python and JavaScript over, adding more languages. We're really excited to see that work, and also for their rules. And of course, some great people have joined our team. So first, we'll start by talking about speed. You might have seen recently the blog post we made comparing Semgrep to Bandit to understand the advantages of each. If in that blog post, we observed that Semgrep multi-threaded on larger repos was as fast as Bandit. That's actually outdated. Semgrep 0.61 compared to the latest Bandit is actually, so on small repos, Semgrep is still slower than Bandit. But on larger repos, even single-threaded Semgrep is faster than Bandit, so 35 seconds compared to 46 seconds for Zulip. And it runs twice as quickly when it's multi-threaded. This is super exciting to us. Our goal from the start has been to make a tool developers will use. And of course, the fastest way to make a developer stop using a tool is to make it too slow to running CI. So if a developer is willing to run Bandit, they'll be even happier to run Semgrep, and that's really what we're looking for. Semgrep's improved a lot since that blog post, which is fairly recent. And even before that, there have been some really large performance improvements. So I do want to talk a little bit about how that's happened, just because it's really exciting to me. So you hopefully did not notice this, but under the hood, we have been replacing most of the engine that's written in Python and moving it to OCaml. So previously, if you had a rule with, like, let's say 2 patterns, we would send those patterns individually to OCaml, which would parse each individual pattern, make the matches, then we'd compose them back and give you your results. So now, instead, while we're still using Python as a wrapper for largely cosmetic reasons, most of the rule is just sent directly to OCaml, where it represents all of that information and then is able to match based on all of it and give you the result. So this is really good because now we have more information to go off of. So one thing is we can use advanced heuristics to skip parsing files. Basically, let's say you have a pattern where all of the patterns include exec. If you have exec in your, if you don't have exec in your file, there's no reason to ever look at that file. But this has been a really big speed up in many repositories. And as a rule writer, you can actually kind of think about this. Like, this is can influence whether your rule is faster or slower. In general, the less Semgrep has to do a lot of searching. So the more specific your rule can be, the faster it will be. Also, having it all in OCaml has enabled some new syntax like metavariable pattern, which Colleen will talk about. And our security team has been really excited about this. We have been able to get rid of patternware Python. Of course, there are some other optimizations. I think they're really cool. I won't talk about them now because we don't have that much time, but you can always hit me up. The other thing that developers really need is for Semgrep to actually support the language that their code is written in. And nowadays, code is written in a lot of languages. So we're doing our best to keep up. We've put in a lot of work, especially courtesy to Martin, who is here, upgrading TypeScript to GA. C# is alpha. Also, we've added a ton of languages. I saw, I think, David Frankel, who worked on Hack and actually just got it to alpha just in time for this meetup, so we can put it on the slide, which is awesome. And a host of other languages added partly by community members. All of this is enabled by TreeSitter, which Martin brought to us 9 months ago, which it's an open source parsing system for programming tools by GitHub. And so TreeSitter itself already has a lot of existing grammars. It makes it reasonably easy to write your own grammar. And so once you have a TreeSitter grammar, we have really tried to make it as easy as possible to then integrate that with Semgrep. As to our success, so you can ask Slack, who David Frankel and Nicholas Lin are a part of. Recently, they presented at DEF CON, in which they said, how easy is it to add a language to Semgrep? Well, an intern can do it, or 2 interns. So that's really what we like to hear. We'll get to questions later, I think. Next slide for now. But someone can answer in the chat too. Also, as part of this, we have made an effort to clean up and improve our documentation. We have moved all of our contributing information into semgrep.dev. So if you want to fix that parse error in Semgrep core, or that like JSON output in Semgrep, or you want to add support for a new language, all of that information is in semgrep.dev. Check it out, read the sections that are interesting to you, and let us know if there's any room for improvement. We also really rely on and love, appreciate all of the contributions to our rules by contributors. So we've made an effort to improve how people learn Semgrep. We've split our tutorial into 3 sections. So if you're new, you can always follow the basic tutorial. You can look at pattern composition, or if you've been using Semgrep for a while, you can go and check out the advanced features. Especially if like you're interested in them by this talk and you want to go through them by yourself to get some practice. You can also, if you really hate writing YAML rules and you just want to like express a simple pattern, we have now created a wizard which will allow you to kind of just input some fields, and then it will generate the rule for you. You can then try it out in this purple box is called an embeditor. And you can just click play. Also, this embeditor, you can include, if you ever write a blog post about Semgrep, you can include an embeditor there. Hit us up if you're interested. We will let you know how to do that. And then once you've written the rule, if you add it to the registry, we will make sure that other people will know where it comes from, who wrote it. And we're also doing some work to add author profiles, so you can really be featured on semgrep.dev. Cool. That's it for now. On to Colleen for rule improvements.
Awesome. Thanks, Emma. Thanks for introducing the Semgrep improvements. So now that we've sort of introduced these improvements, we can move on to talking about the changes we've made to actually help you write rules you weren't able to write before. So a lot of these changes will also help you write rules in fewer lines and with less false positives. I'll primarily be talking about some new keys we've actually introduced into our pattern writing YAML, and these keys will actually help you write even better and more exciting rules. So the first new key I'd like to introduce is something called Metavariable pattern. So what this actually does is it lets you perform pattern matching on metavariables. So this can be nested and it can actually also be used with a different language than the original pattern. So I'll show you an example of this in the next slide. So if you look towards the left, we see that this is the metavariable pattern syntax. So you just can use metavariable-pattern as the key, and then metavariable with the name of the metavariable, and then a specific pattern specified. So now you can actually match patterns inside patterns inside patterns. So here's a quick example of a metavariable pattern rule. So in this scenario, we actually want to prevent users from injecting malicious code into website HTML content. And in order to do this, we have to be aware of raw HTML concatenation, because this can actually result in cross-site scripting and your cookies or other important information being stolen. So what this raw HTML concatenation does is it uses metavariable pattern in order to prevent raw HTML concatenation. So if we look at the Semgrep rule to the left, we see that the pattern is a $string plus $expression. So it's two metavariables, and we can use metavariable pattern to specify that the string is actually a HTML tag. So we're looking exactly for the raw HTML concatenation that we said we would be. And so we can use this, as you can see, on a language JavaScript, and then use metavariable pattern to look for HTML inside of the JavaScript. We can also look for instance, JavaScript inside of HTML and combine other languages like this. So another thing I wanted to really showcase is that metavariable pattern is also really useful in reducing the number of lines and actually simplifying the patterns that we've already written. So one of our rules that used to be actually 88 lines of code, we actually were able to reduce to just 18 lines of code. And as we all know, the less YAML, the better for us. Awesome. So the next key I wanted to talk about is metavariable comparison. So essentially, we use it to compare metavariables against a basic comparison expression. And essentially, if you've ever come across the dangerously allow arbitrary code execution from rules flag that you need to set in order to run patternware Python rules, you can probably tell that patternware Python can be pretty potentially dangerous. In a sense, you have to trust the rule author to not have injected malicious code into your rules. So this is where pattern or metavariable comparison really comes into play. So metavariable comparison actually lets us replace your usage of patternware Python for a more secure key. So essentially, as we were saying with patternware Python, you had to trust the rule writer to not actually inject malicious code into the rule because there's no actual sandbox that contains the harm that the Python code can actually perform. But with metavariable comparison, you don't actually need to trust the rule out there at all, because the interpreter running the comparison can't actually run any arbitrary code on your systems. So this is much more safe and essentially much more secure than the pattern word Python we were using before. And here's an example of a metavariable comparison rule. So we want to make sure that unneeded permissions are not set for files with actual important private information. So chmod with the octal 600 mode actually allows only the file owner to read and write to the file, and any value or mode above octal 600 actually gives more permissions than that. So we want to make sure that others don't have unnecessary permissions to our files containing private information, and we want to catch cases where we set file permissions to something greater than octal 600. So if we see the Semgrep rule, we see that we're actually using a pattern with metavariable comparison. And we see that there's this base key that essentially we've set to 8. And what this base key does is it interprets metavariable values found in the code with the specific base. So if we give 8 to this base key, this means that the metavariable values are interpreted as octal. And if we see the target code, we'll catch the case where we're doing chmod with mode octal 700, but chmod with octal mode 400 is okay. Awesome. And the last key I really wanted to talk about, or essentially the last improvement I wanted to talk about, is ellipses metavariables. So what ellipses metavariables does is it combines ellipses and metavariables. So with this, we're able to actually match a sequence of arguments and store them in a metavariable. And you can use this to store arguments and run metavariable pattern on them, metavariable regex, or use them in a message or with autofix. Awesome. So in this case, we want to enforce another security default. So when we set a cookie, we want to make sure to actually set it with secure headers like HTTP only, which protects the cookie from being read with JavaScript, and secure, which actually limits the cookies to HTTPS traffic only. So if we look at the Semgrep rule, our pattern is flash.response.setCookie with the ellipses metavariable. And essentially, we can use this to capture the contents inside the set cookie call and write an autofix with the original contents along with HTTP only set to true and secure set to true. So essentially, we're able to use autofix with ellipses metavariables in order to write better autofixes. Awesome. And that's the 3 things I wanted to talk about. So I'll pass it to Vasily for Taint mode improvements.
Yeah, cool. Thanks. So Taint mode improvements. Taint mode for a long time was an experimental feature that was hiding deep in our documentation. And well, the main improvement here is that it is not anymore. It is available to everyone from the current version of Semgrep. On the next slide, let's talk a little bit about taint checking in general and a brief explanation of this concept. So let's say that we have a web application. In this example, it is Python Flask. And let's say that we want to make sure that no dangerous deserialization is going on. It can happen, for example, if user control the input gets to pickle loads function in the bottom of this route. And we want to make sure that user cookies represented by request.cookies.get are not reaching this dangerous function. But we don't care if it is touched by anything else. We don't want to know about it. All we care is just if cookies somehow reach to the pickle loads function. And on the next slide, I highlighted what is in the concept of taint tracking, how this part's going to be called. So the request.cookies.get going to represent source, like a source of user input, or for example, like a source of danger, and pickle loads will be a sink here. And all we want to do is we just want to know if source reaches the sink. So on the next slide, we can see how potentially we can find this type of vulnerability with Semgrep rule. Now, the first option would be find all pickle loads usages and filters those that have constant values. It usually works because AppSec people want to be aware of such such functions that they're presented in the code anyway. But the disadvantage here that like there is a possibility of hitting a lot of false positives. And the second option is to try to tackle as many possible scenarios of where the variable can go, but you're probably gonna forget about something, and there is a chance that you like will miss some dangerous bug. And let's see on the next slide how we can solve this with the new Taint mode. It's just as simple as writing a rule in general. Here you can see and like new type of configuration, an example, and all you need to do is to specify the pattern that will be identified as a source and specify the pattern that's going to be a sink. And Semgrep rules, they are like they're as simple as the code that you write, and Taint rules, they're as simple as general rules. So like it's very simple to write those rules. Here we say, in this example, we say that request .cookies.get, like on a previous slide, it's a source, and Piccolo send is the sink. And as you may already notice, like on the slide that is going next, that it works and with the new Taint mode, and we can highlight this situation, this type of vulnerability. And the link, like some good people gonna post this working link to the playground to the chat, so you can try it yourself. And we're moving on to the next slide, where we go into like wonder, what if the input that we have is sanitized? For example, we worked a lot on making like this situation safe. We created a sanitizer. We don't want to spend no more time on this, and we don't want to highlight this finding. So that's very easy. On the next slide, you can see that all you need to do just to add an optional parameter called pattern sanitizers. I believe no need to mention that it is just a Semgrep pattern that will be identified as a sanitizer, and if this sanitizer is present, those findings like will be cut and you will not have it. So on the next slide, like we're gonna discuss a little bit about possible limits that we have. And if, for example, you used to have experience with other tools for Taint tracking, you may wonder like what languages are supported or what functions exactly it can work with. So the thing is that Taint mode works for all languages, and the only limit here is your creativity. Any pattern can be a source and any pattern can be a sink. So you can have nested logic like in your other patterns with pattern either, pattern inside, etc. You can use all the features that Colleen mentioned previously. And also on the next slide, I would like to mention that despite the fact that there are almost no limits, there are still a little bit of some. So, but only those that follow our philosophy, which is not only find bugs, but do it quickly. That is why Taint is working only inside one file for now. And for this particular moment, the Taint is scoped to a function. So everything within a function on the slide is going to be covered. Those parts that like in green. But if, for example, request.cookies reside like in another function, so you would need to change the rule slightly. But no worries about that. On the next slide, you can see that Taint still has a lot of advantages. One of them is that Taint mode rules, they have better readability, they're simpler to understand, and as a result, they're easier to maintain. So for example, on this picture, but I not try to see the actual code, I tried to like zoom out, but still wasn't able to like fit all the 315 lines of code. On the left side, there is a JavaScript rule that we had, and now with the Taint mode, it's just 43 lines of code. And as a bonus, it has much better precision for this rule. And this rule is already available in the registry. You can try it. And we're moving on to the next slide, where like as a kind of conclusion, we can see how the Taint mode rule look like. In this rule, we explicitly say, hey, this is a Taint mode by like writing mode Taint. We specify pattern sinks. We specify pattern sources. And optionally, we can have pattern sanitizers. All the magic is done by the Semgrep. And on the next slide, like speaking of all this magic, which is, by the way, provided by our program analysis team. And most of the work was done by our PA engineer, Iago, who is a genius, and he's an expert in Taint tracking stuff. So all the credit for this thing goes directly to him. And despite all the work that happens under the hood of the Semgrep with this Taint mode, it has similar performance to general Semgrep rules. We're actively testing it right now, and we see that the numbers are usually pretty close. So, but obviously, like Taint mode provides better precision in situations when you need to track user input. And given all that, you shouldn't hesitate to try new Taint mode because it is awesome. Please use it and report any issues to us, like links to the Slack channels, Twitter will be provided. Thank you. Who's next?
Awesome. Thanks, Vasily. Hello, everyone. I'm excited to share with you the Semgrep roadmap and our plans in 4 areas. So the languages, Semgrep binary itself, how we're making it easier and more powerful to write rules, and last but not least, semgrep.dev. Our goal with Semgrep is to support every major programming language in the world. And you might ask why? Well, it's because bugs and, more importantly, security vulnerabilities are no longer contained to a single app or a single programming languages. Today, you don't have a Java app. You have a Java, Spring, Lambda, you name it, third-party APIs, Docker, Terraform, iOS apps. I just looked at a couple random projects, and you can see that like every company has multiple languages and multiple frameworks. And so we need to be able to understand the different boundaries and find bugs in all these and write secure guardrails to ensure the whole program is secure. As Emma mentioned, we support 19 languages, and we're adding more languages all the time. Next slide. Our goal for this quarter is to add 5 new languages. And if you want to take a minute and go over to the Meetup channel in our community Slack, there's a nice poll that you can vote on the languages you're most excited to see. We'd really appreciate that feedback. But what we're thinking about right now is C#, Scala, Kotlin, C++, and Bash. And I want to give a special shout out to the community who's already started work on Rust and Hack and Terraform and a few other languages. If you're interested in contributing your own language, we'd love to help. And I want to give a special thank you to everyone on this call who's already contributed bugs and examples of things that they want to match. It really means a lot to us, and it helps us make sure Semgrep works across the language properly. Down the road, we're also thinking about .NET and SQL, Perl, and Swift. So it's kind of next in the pipeline for us. And briefly, just what we think about different languages. So we think of alpha support, which means it works, and you can start to maybe match some of the language features, but not everything. When we get it up to beta, that means we've been using the language, we've been writing rules, we feel really confident, we're ready for people to start running this in production and give us early feedback. And then finally, when it's generally available, we think it's ready for production use, and we're actively supporting that. So we're a bunch of developers, and we wanted to build Semgrep for ourselves. And we've had a couple goals here. We wanted Semgrep to be super fast, should work completely offline, be transparent, understandable to the developer what's happening, and of course feel native to their environment. So last quarter, as others have mentioned, our goal was to get Semgrep running in less than 5 minutes on most scans in the CI context. And a big thank you to GitLab, which gave us some pretty cool performance stats showing that 95% of runs happen in under 4 minutes. Right now, we're working on the startup runtime, and our goal here is to support all of the editors. And what we need to do that is have Semgrep run on a single file in under half a second. We're also working on offline rule caches, improved autofix, and a new registry that supports like fully deterministic runs via local config file and lock file. And we want to make sure that anyone can write static analysis. So our philosophy here is we're not going to find every single bug. We'd rather trade off and make Semgrep fast and easy to understand. But if a senior engineer could look at a single file and say, hey, this is probably not secure, you should be able to write a Semgrep pattern to detect that and also enforce that that doesn't happen in the future. So we're working on taint analysis, the pattern composition, and a new meta checker that will auto-suggest the latest syntax to write more precise and performant rules. We're working on some subcommands here that lets you log in and publish your rules and distribute it out to the world, doing more semantic analysis where we're propagating the expressions and constants throughout the file. And then, of course, checking to make sure that we're not breaking old rules and that we're not slowing them down. And finally, we have semgrep.dev, which you can think of as Semgrep as a service. Our goal is to make it easy to do effective AppSec using Semgrep. It already has a bunch of cool features like fix rate, finding new bugs that have been introduced recently in your code base, one-click setup for both GitLab and GitHub, including comments on PRs, and you can go to semgrep.dev to see more details. 3 features we're really excited about. So automatic rule recommendation based on the code that you have in your repository and the frameworks you're using, more expanded private rules and rule sets, and finally a webhook and REST API so you can integrate it in the security workflow.
Awesome. Thanks, Drew. So yeah, I think short and sweet, that kind of covers a subset of the work that we've been doing and the work that we plan to do. But we'll open it up for questions, and there are a bunch of links here to some of the things that we mentioned inside the presentation. The last thing I will say is that we are, of course, hiring across security and program analysis positions especially, as well as engineering for people who are interested in these sorts of problems. I can tell you there's a lot of, big spectrum from like fun, interesting, deep computer science problems on the PA side to really meaty security problems on the other side. So feel free to reach out if that's something that you're interested in. And yeah, I'll open it up for questions. You can throw them in the chat or unmute yourself. And actually, I should make sure that we answered all the questions that were asked in the chat already. But I think we did. So with regards to HCL, actually, Mitchell, who's one of the co-founders at Hashi, contributed a tree sitter grammar for HCL recently himself that he expressed would be suitable for integration into Semgrep, which was pretty cool. And then Flint, it looks like you've got the, you already answered the question about the sort of level of maturity for rules that accompany the engine support. Julian, your question about taint tracking has gone GA. So we officially promoted it from an experimental feature to something that will be supported going forward. And we're actively rewriting a bunch of old rules that were written using the search mode to now use the taint mode. And we'll be tracking the kind of like performance of that and using it to do some like essentially profile guided optimization. Clint, do you want to answer Tim's question or the implicit question there?
Yeah, that's a good question. I'm not quite sure about different compliance requirements, but I would say for like new languages, one of the first things we do, actually like the security team and program analysis team sort of work in parallel. So basically they're like, hey, we have got like a pretty good parsing and pretty good analysis, and then we write some rules and we find some bugs and they improve it, and sort of this back and forth collaboration. But generally when any language gets to, let's say beta or GA, we generally try to have at least say 20 to 40 rules that are covering general like OWASP top 10 type things. Yeah, so generally we try to, like before we announce a new language, we make sure there's at least some value out of the box. So it's not just like, yeah, you can write your own rules. I don't know, does that help?
But it's certainly true that, like usually when we're talking about language maturity, we're thinking about it from a kind of engine perspective. So if you click through to the documentation, you'll see that we're interested in kind of like, hey, what is the successful parse rate percentage? And I think we also need to have a better, like tracking of kind of what is the OWASP coverage for this language. I know if you go to the Semgrep rules repo, there's some preliminary work, and there are some scripts that can calculate those sorts of stats, but it's not as kind of easily accessible.
Yeah.
To get at the question.
Language maturity is different than compliance maturity. definitely. It's a different rating. For using a tool for like a large organization, compliance maturity is probably more important than language maturity, because 1% is probably like not much at all for a language.
Yep, that makes sense. Ross has a question about the work on the Scary Depths project. So that is currently being dog-fooded on the Semgrep repo. You may have seen some of that going on. It's basically stable right now. It's not necessarily ready for external consumption, but there are a couple partners that we're talking with. Broadly, I'll just say that they're people who are kind of interested in open source supply chain maturity and development, who may be like kind of more suitable people to push that project forward. And then Vincent, were you talking about Semgrep generally, or were you talking about taint tracking or C++? Just because we were generally, Pablo, do we have a I know we have a YouTube channel that has a bunch of videos. Is there anything short?
Maybe Grayson made a shorter one. Most of the YouTube videos that we have up there are kind of this length, meetup length style, but I'll look to see quickly and put something in the chat if I find something.
There is an animated GIF on r2c.dev, which kind of shows going through the progress of writing a rule and inserting it into the autoflow that people have said is a kind of pithy introduction if you're looking for something. Oh yeah, and there's a video in /learn.
Hello, this is Grayson.
Oh, someone's speaking, but they're very quiet. If that was you, put your question in the chat. But Pablo, I guess back over to you. I think we've covered most things. Don't want to monopolize the stage.
Sure, yeah. In the Meetup channel in Slack, feel free to add another language that maybe we didn't add as an option there. You can add your own option to the poll. We're not going to close the channel tonight or anything like that, so feel free to think about it if you like, or come back to it tomorrow. And also, if you want to chime in on particular issues in the Semgrep repo, many, but probably not all of those languages may have an issue associated with them, so you can also upvote there and add any relevant discussion or things you want to see to that. I did find a short-ish video, about 12 minutes long, that you might want to take a look at. And if you Google Semgrep, you'll probably find a few blog posts that are relatively short and sometimes have a little bit of a screencast. For example, Abhay Bhargav made one a few months ago that also showcases Semgrep in action. It's a little bit more iterative and kind of live coding style.
Oh, could I tease a quick thing? So look, in the next few months, look for a pretty meaty, exciting blog post we're going to drop. We've been spending a lot of time thinking not like how can we find individual bugs, but how can we try to knock out entire vulnerability classes, because we think that's a much more exciting and promising approach. So a lot of people, like big FANG companies, talk about sort of secure defaults, and we try to sort of say like how effective is this in practice using sort of real world data. So yeah, keep an eye out for that.
Thanks, Lint. And was there someone else who wanted to say something?
I was just going to say, thanks to all the people in the Slack or on the Meetup here who have contributed language improvements, rule improvements, reported bugs, helped other people on the Slack, which is pretty cool. And to Bobby's question about is it possible to use regex for the pattern sanitizers, the answer is actually yes, which is sort of mind-blowing. Then, Clint, do you want to take Vincent's question?
Yeah, so we tag rules with like OWASP Top 10 and CWE, and our current severity is sort of info, warning, and things like that, but we're moving to sort of low, medium, high, critical, or informational in the near future. I don't think we're going to end up doing CDSS because that depends on like exploitability and a couple of other factors that you would need sort of context of the node, the code and surrounding stuff to know, which can't really be known statically, but could be known by you as someone who knows the code base. So yeah, probably will be like low, medium, high, critical, but probably not like a CDSS number, just based on that requires context we don't have.
I would add that we have seen some people kind of building systems that will contextualize a Semgrep finding based on their threat model of the repository. So because it's such a pluggable system to be able to work with, you can kind of do your own mapping. And we've got a lot of metadata now inside the Semgrep rules that people are starting to use as inputs to that function, but it can be a lot more org specific than us just putting out a generic identifier or generic number. Cool. Back to you, Pablo. I think we've covered all the questions.
A question from Pony.
Putting, there are experiments going on with language server protocol for cross-file data flow analysis. I don't know if anybody, I remember we evaluated Pisa back over a year ago at this point. And if I remember correctly, when we sat down and chatted with the team at Facebook, which Johan, who's on the PA team here, used to work with a bunch of those folks, they were much more interested in kind of developing it as a type checker and not so much in the development of inference. And so that actually meant that it was sort of less suitable for our purposes because it wouldn't give you a lot of information on an untyped Python code base, only one where there were explicit annotations already. But it's certainly possible that that changed. Yeah, would love to, if you have more information about it, would love to chat.
Anyone else have any other questions or comments? Sweet. Well, thanks everyone so much for attending. As I mentioned earlier, or if you missed it, we'll upload this to YouTube and share it. And also you'll be able to download the slides, a copy of the slides, so you can click on all these links very easily and look at them on your own time as well. And also to echo what others said, thank you so much to everyone who's contributed, be it by issue or PRs or just for your support or asking questions or helping others in the community. We really, really appreciate all of your support. It's great to see.
Thank you folks so much.
Bye everyone. Have a good evening or a good day.
Thanks to all the presenters.